Hello students, welcome back. Today we'll continue with the examples of chapter number 9, that is ray optics and optical instrument. In our last video lecture, we had completed till example 9.6. So let's start with example 9.7. So see, what is example 9.7? A magician during a show makes a glass lens with refractive index n equal to 1.47, which disappears in a drop of liquid. What is the refractive index of liquid? Could that liquid be water? Okay. Now see, when we observe a glass or a lens, the reason why it is visible, because when the ray of light enters in the medium of glass, it bends towards normal, right? So due to this bending of light, glass is visible. Okay, the transparent medium are visible because when ray of light passes through it, it does not pass it straight. Okay, it deviates, and due to that deviation, these objects are visible. Now, it is said that when the lens is placed in a liquid and it disappears, so if the lens disappears, that means the light rays are passing through the lens without deviation, right? So when is this possible that the light rays will not bend? This is only possible when the refractive index of the surrounding and the medium both are same. As they will have same refractive index, light will pass without any deviation and the object will remain unnoticed, means it will disappear. So the refractive index of the lens will be equal to 1.47, then only it will be invisible, sorry, not of lens, of the liquid. Of lens it is given 1.47. So of the liquid also it must be 1.47 so that the lens disappears. Okay. Now the second question. Could the liquid be water? We have to say no, it cannot be water. Why? Because refractive index of water is 1.33, or I will write it down 4 by 3, right? So the refractive index of water is, as it is 1.33 and the refractive of lens is 1.43, obviously light will bend and the lens will be visible if it is a water. So that liquid cannot be water. Okay, it can be glycerin. The refractive index of glycerin is very close to this. Clear? So this was about example 9.7. Now let's move to the next example, that is 9.8. Question number 9.8 is, it has three sub questions. First, if f is equal to zero point 0.5, so first let's write down f equal to zero point 0.5 for a glass. 0.5 meter. What is the power of length? So what's the formula for power? Reciprocal of focal length. So this will be 1 upon 0.5, and this will be equal to 2 diopter. Okay, so this was the first one, focal length 0.5. So the power will be 2 diopter. Clear? So just note it down. Okay, the second one, the radii of curvature of a double convex lens are 10 centimeter and 15 centimeter. So what I can do, if I take R1 equal to 10 centimeter, R2 will be equal to minus 15 centimeter. Reason, if this is a lens, if this will be the area of curvature of this side, from this way it is positive, then on the other side for this surface it will be negative. So for a lens, when you are taking two radii of curvature, one will be positive and other will be negative. Okay. Now focal length is 12 centimeter. Clear? Now see, for a convex lens, the focal length is always positive, 12 centimeter. What is the refractive index of a glass? Okay, so which formula I can use here? 1 by F is equal to N2 minus N1 upon N1, 1 by R1 minus 1 plus 1, sorry, yes, minus 1 by R2. Clear? Here N2, that is the refractive index of glass, and N1, that is the refractive index of air. So that is 1. So 1 upon, what is the focal length? 12. N2 minus 1 upon 1, 1 by 10 minus 1 by minus 15, so this will be plus. Clear? So 1 by 12 and 2 minus 1, and I will take LCM, it will be 30, or else let's take 150, 10 into 15, cross multiply 15 plus 10. So 1 by 12, I will take this on this side, 150 in the numerator, divide by 15 plus 10, 25 in the denominator. This will be equal to n2 minus 1. Okay, so remember this is multiplied. So 150 which is divided will be in the multiplication numerator, and multiply it is in the denominator, that is division. So 25 ones are 25 six are. Clear? So 6 by 12, that is 0.5 equal to n2 minus 1. That means n2 is equal to 0.5 plus 1. The refractive index of the glass lens is 1.5. Clear? Here we use the formula for lens maker, that is 1 by F, N2 minus N1 upon N1, 1 by R2, R1 minus 1 by R2. We put the value of R1, R2, N1 and F, and we got the value of N2, that is the refractive index of glass. Clear? Glass lens. Clear? Just note down the second part of example 9.8. Okay, now let's move to the third part. Now, see what is third part. Convex lens has focal length 20 centimeter in air. So what I will write down? FA equal to 20 centimeter, right? What is the focal length? What is its focal length in water? So see, what is the question? When the lens is in air, its focal length is 20 centimeter. Now the same lens, when it is kept in water, what will be its focal length? Now remember, when you change the medium, the focal length of the lens will change. Clear? So the focal length will not be equal to 20 centimeter in water, right? So let's find it out. Okay. Now, so given the refractive index of air water is 1.33. Means refractive index of water between air and water means refractive index of water with respect to air. I will write it down as 1.33, and that for air glass, when light ray enters from air to glass, it's 1.5. So for glass, it's 1.5. Clear? What is the refractive index of air? 1. Okay. Again, I will use the lens maker formula. So now first, for air, means when the lens is in air, 1 upon FA Ng minus means N2, medium of lens, that is glass. Now let's take this as NL. Okay, is it yes. It's given glass, so I will take only Ng. Ng minus Na. What is Na? 1. Upon Na, 1. 1 by R1 minus 1 by R2. Remember, the radius of curvature doesn't change. When the medium change from air to liquid, then radius of curvature remains same. Now for water, means when the lens is kept in water, 1 by Fw. Clear? What is it? Refractive index of water, sorry, glass minus refractive index of water. Clear? See what happened? In first case, this was glass lens, air. In second case, glass lens, water. So Ng minus Na, Ng minus Nw. Clear? So this will be Ng minus Nw upon Nw 1 by R1 by 1 by R2. Equation 1, equation 2. Now let's take the ratio. Taking ratio of 1 and 2, it's 1 by Fa upon 1 by Fw. This will be equal to Ng minus 1 upon 1, Ng minus W, sorry, Nw upon Nw. 1 by R1 minus 1 by R2, even here. So what will happen? This will get cancelled. Clear? So now there is a ratio in 4 terms. So first and fourth will multiply and second and third. So 1 into FW, FW. FA into 1, FA. Ng minus 1 into NW upon 1 into Ng minus NW. Clear? Into 1. So what does this imply? Focal length of water. What is focal length of air? 20. Focal length of air is 20 centimeter. Ng, that is equal to 1.5 minus 1 into 1.33. 1.5 minus 1.33. So this will be 0.5 into 1.33 and 1.5 minus 1.33, that will be equal to 0.17. So what will be the focal length in water? 0.5 into 1.33, this 20 will be multiplied upon 0.17. Clear? So let me calculate it. 0.5 multiplied by 1.33, 20. divided by 0.17. It's 78.23. Focal length of water will be equal to 78.23. Clear? Okay. So this is an important question. What we have to do for air lens maker for water, taking the ratio. Okay. And then finally we got focal length of lens in water will be equal to 78.23 centimeter. Clear? So just note down the third part of example 9.8. Now let's move to the next, that is example 9.9. In question number 9.9, it is find the position of the image formed by lens combination given in figure. Now see here there are three lenses given. The convex lens having focal length 10 centimeter, then concave minus 10 centimeter, again convex 30 centimeter. These are three lens given in combination. Okay, now an object is kept here at 30 centimeter in front of first lens. Okay, you have to find out the image formed by the combination of these lines, the position of the image form. Okay, so what we will do first, we'll use the lens formula for this. Clear? So first let's take lens 1. What is lens formula? Okay, first write down 1 by v minus 1 by u equal to 1 by f. Now for first lens, what is u? Where is the object? 30 centimeter in front of convex lens. So u will be equal to minus 30. Clear? And what is f? 10 centimeter. Okay, so let's find out the image, position of image formed by the first lens. So 1 by v will be equal to 1 by f plus 1 by u. So this will be equal to 1 by 10 plus 1 by minus 30. 30 into 10, 300. 30 minus 10. Okay, so 1 by v will be equal to, or v will be equal to 300 upon 30 minus 10, 20. So that implies v is equal to 15 centimeter. Okay, so the image distance from the first lens is 15 centimeter and it is plus, so it is on this side. Clear? Now that image will act as object for second lens. Remember, this is the object for first lens. Image formed by first lens acts as object. And where is that image? 15 centimeter on this side, right? So 15 minus 5, 10 centimeter will be the object distance for second. So let's take for lens 2. Okay, what is the object distance? Here it's 15 minus 5. So u will be equal to 10 centimeter. It will be plus because it is on the right side of this. Okay, now focal length minus 10. So 1 by, I will use directly this 1, 1 by f plus 1 by v is equal to 1 by f, that is minus 1 by 10. plus 1 upon what is u? 10. Clear? So this will be equal to 0. So V is equal to infinite. 1 by V equal to 0. So V will be equal to 1 by 0. That is infinite. So the image obtained by the second lens will be at infinite position, right? And it will be obtained on the right side. Clear? Sorry, on the left side of this lamp. This image will be obtained on the left side of this lamp at infinite position. So if the object that will act as object for the third lens. Now where is the image of this lens? Image formed by this lens? Infinite. So now that acts as object. So object is at infinite for this lens. So image will be formed at the focal point. Okay? Or else lens 3, we can take object distance as infinite. The image formed by this lens is at infinite. So that will be acting as object for this lens. So object distance infinite, focal length is 10. So I will use again the same thing. 1 by v will be equal to 1 by f plus 1 by u. What is 1 by f? 1 by 10, 1 by u, 1 by infinity. 1 by infinity is 0. So V is equal to 10 centimeter. So now the image is obtained at a distance 10 centimeter on the right side of lens 3. So I can write it down. Image is obtained at 10 centimeter on the right side of lens 3. Clear? So I'm revising what we did. First, we use formula for this one, lens formula, and find out the image distance. Now this acts as object, so 15 minus 5, 10. Now this lens, the image of first acts as object for second, and then image distance infinity. Now the image of second acts as object for third, so u is infinity. And finally we get v equal to 10. If you don't want to solve this, and logically also you can say that when the object is placed at infinite, the image will be obtained at the focal point. Clear? So that is 10. Okay, sorry, this focal point is not 30, it's 10 centimeter. Clear? So just note down example 9.9. Okay, students, so that's it for today. In our next video lecture, we will start with refraction through a prism. Okay, thank you.